All right, welcome guys. We are on 3.2, graphing linear inequalities. Now we've solved linear equations already. We've learned how to graph lines by now, and we also did inequalities on a number line. What's different today is we are going to do them on a coordinate plane. Okay, so we have our things to know section. We got this term, it's called a half plane. And this is the graph of a solution set in a coordinate plane of an inequality in two real number variables that is linear and strict. Okay, and what this means is we're going to actually have a specific region that covers the vast amount of solution sets to our inequality. And remember, a solution set to an inequality means that we are making a true statement. Okay. The thing that's different from graphing linear equations, okay, if you go back to our inequality lesson, we knew that on the number line, if we had greater than or less than, there's no underline here. We graphed on the number line using a open dot. And if we had one of the equal to inequality symbols, remember we used a solid dot or a closed dot, okay? Since we are graphing lines, okay, on the coordinate plane, we're going to have to distinguish between these two, and we do that using two separate types of lines. Okay, so when we have the greater than or less than, we're going to be using what we call a dotted or a dashed line. Just make sure you have some breaks in between the line and always have those arrow tips, right? Okay, and then if you have the greater than or equal to, or the less than or equal to, we are going to use the good old-fashioned solid line. This lets us know that anything on the line we are including, and then over here anything that is on the line we are not including. Okay, so it's very important that you commit these two to the memory bank as we're going to be using them. And then again, we have our slope-intercept form and our standard form. This is important to know because we are going to want to convert to slope-intercept form so that we can make nice, easy graphs. All right, let's take a look here. Okay, we have example number 1. It wants us to circle each ordered pair that is a solution set to this inequality, meaning we are going to substitute. We have our x value and our y value, and we're going to plug these in here, and we want to make sure that whatever we evaluate on the left is actually indeed less than or equal to the number 10. So that means we can get 10 here and any number less than 10. Okay, so I want you guys to grab your TI-84s. I'm going to show you something on the calculator that's going to make this process really easy for you. Okay, so get out your calculator, get to the home screen. Okay, I'm going to pull mine up here as well. All right, now that I got this up for you, what we want to do is we want to plug in our x and our y into this section of our inequality. Okay, and an easy way we can do that is we're going to hit the number 4, right? And then we want to use parentheses to do our multiplication for us, and we're just going to do this in one fell swoop. Okay, so we got 4 times our x value, then we have the minus right here, and we're going to parenthesis for our y value. Okay, and then we are going to hit enter, and we do get 10. Okay, so is 10 less than or equal to 10? Yes, it is. So I would want to go ahead and circle this first one. Okay, the other thing that I want to show you, a neat little trick on here, as you go through these, if you want to populate what you previously wrote, we can use this function here by hitting the second button and then hitting enter. Okay, it's going to pop up what you typed in previously, and then now all we need to do is tab over to our parentheses and substitute the values with the other ones we are working with. So let's go ahead and do that. We got x is 2, y is 3, we hit enter, and then we get 5, and yes, 5 is less than or equal to 10, so we are going to circle this one as well. Okay, go ahead, pause the video, crank out the rest of these, circle the ones that are correct, and then come back and check yours on what I have. Alright, welcome back. Hopefully you got all the same ones that I did. Okay, it looks like everything except for these last two are solutions. So our next piece wants us to actually plot the ones that are solutions onto this coordinate plane. Okay, I'm going to walk you through this first one, and then I'm going to have you guys plot your points. Remember, this is the x, this is the y, so it says to go over to the 3 on the x, and then go up to the 2 on the y, and then I'm going to put that dot right there. Okay, go ahead, pause the video again, place all your dots here on that graph, and then come back and we'll go on to the next part. Alright, welcome back. So I got all of these dots right here. Okay, our next piece is asking us to graph the line by converting from standard form to slope-intercept form. Okay, so remember, we have this inequality right here. So the first thing I would want to do is I would want to write this down. So I got 4x minus y less than or equal to 10. And then remember, slope-intercept form, I want my y term by itself. I always get rid of this x term by doing the inverse operation, meaning the opposite. So if you have a positive 4x, we're going to do a negative 4x. Okay, these will go away. We drop down the negative y. Okay, then we got the less than or equal to. We should always put our x term first. Okay, so we got negative 4x, and then we have this plus 10. Okay. However, when you end up with a negative variable that you have solved for, remember, it can never be negative. We need to distribute this negative out. We can do that by dividing every term by negative 1. But there's also another piece of information that you need to recall from inequalities. Anytime we divide or multiply by a negative number, this sign direction needs to flip. So we got a negative over a negative, which will give us a positive y. Since we divided by a negative, we must flip the sign. Negative 4 divided by negative 1 is going to be a positive 4 over 1. Let's go ahead and leave that as a fraction because we want it to be our slope. We should take this x out of the numerator and just slap it right here following the fraction so we can identify our slope. And then we have this 10 divided by negative 1, which is negative 10. Okay. The piece that you guys need to remember when graphing these lines, remember the value to the left of your x, this is your slope. Okay, your slope is what we call rise over run, meaning, okay, we have our y term above our x term. The numerator tells you how many units to go up or down. The denominator tells you how many units to go left or right. And the other important piece is this non-variable term. Okay, so the term that has no variable, the one that is just the number, this is your y-intercept. Okay, and we're going to be using, let me just highlight this for you. Remember, we always start on this y-axis. Okay, so this y-intercept is always going to start on this up or down line. Make sure you are doing that. Let's get rid of that. Okay, so let's go ahead and plot this. We have negative 10. That's going to go right here. And then our slope is positive. So positive means we go up and to the right. So we're going to go up 4 units and to the right 1 unit. So 1, 2, 3, 4, and then to the right 1. Let's go ahead and put as many dots as we can, just because it's going to help us get a nice, organized and neat looking and precise graph. We want to be as very precise as we can be. So now that we got all of our dots, we want to look at the inequality sign. This is greater than or equal to. So remember, if you have a greater than or equal to, we want to use a solid line. So make sure you have your straight edge, so you draw a nice straight line. I'm going to try and make mine as perfect as I can. And boom. Now I have my line. I got my arrow tips. I have my straight, not dotted line. Okay, it's the solid line. And let's take a look. Okay, we want all the values that are greater than. Okay, so if we looked at all of these solution sets, do these look like they would rest above the line? Okay, this dot touched here at 510. Does it look like we touched 510? It sure does. Also, what about this one, 1, -6. It looks like 1, -6. Okay, and then all these other dots are resting somewhere over here, and we're going to learn how to shade in the next example. But greater than means to go above, and it looks like all of these points would be above this line. Okay. All right, so we're going to do two things here. We're going to do how we're going to graph by just shading, choosing the up or down. But if you ever do get confused of which direction to go, we can use this 0, 0 point check to help us. Okay, so we want to graph this. We are already in slope-intercept form, nice and easy. This is my y-intercept. So I go ahead and I put a dot at +2. I have a slope of 2. I can go ahead and put this as 2 over 1. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Then I retreat back to my original y-intercept, and then I do the opposite of up 2 over 1, which is down 2, back 1, down 2, back 1. Okay? Make sure you are plotting as many as you can. Now I have the less than. That means I need a dashed line. Okay, so I'm going to use this one right here. Let me go ahead and fix this a little bit. All right, I think that looks a little bit better. Okay, now we want to figure out how do we figure out the shading. So this little note says if it is less than, you want to go below the line. If it is greater than, you want to go above the line. So our case, y is less than, so this means we want to go below this line. Okay, so we want to shade everywhere we can below this line. Okay, so if you have some colored pencils, that can work, or you can just shade really lightly with your regular pencil, or you can just draw some hash lines. Just indicate that you are below this line. Okay, go ahead and pause the video here. We have the same graph right here, or the same inequality. Go ahead and graph this real quick, and then I'm going to show you what this 0, 0 check is. All right, welcome back. Hopefully you didn't color it in yet. I forgot to mention that earlier. If you did color it in, that's okay. This will still work. But I want to show you before I actually color it in. So when we've been dealing with equations and inequalities, the one thing that we've always been looking for is these true or false statements, right? Remember, true is something included, false is something that we don't really include. So we can use what we call the 0, 0 point check. Okay, and this only works if your graph does not cross the origin 0, 0. So most of our graphs are going to be able to use the 0, 0. If not, you can just use any other point. But you would want to use a point either above or below to determine which direction to shade. So it says if the test point is true, like if we picked a point over here, plug this in, and it was true, we would want to shade to where we cover that point. If the test point is false, so if we chose this point and it was false, we would just shade the other direction. Okay, and the reason why 0, 0 is the easiest is because you don't really have to multiply anything. Everything just turns into a 0. All right, so let's go ahead and do that now. I'm going to use the 0, 0 since we're not crossing at the middle. We're just kind of right here. So this is the point that I'm going to check. Okay, 0, 0. So that means I have a 0 for y. Okay. And then I got 2 times 0. And then I have this plus 2. Okay. What is 0 times 2? That is 0. And then 0 plus 2 gives me a positive 2. And then I ask myself, is 0 less than 2? Yes, we know that 2 is greater than 0, so that means 0 is less than 2. So this is true. We want to shade in a direction that covers that point. Okay, so if the point is here, I want to make sure that I'm covering that point. And if you notice, it looks exactly like the shading that we did in the previous graph. So this lets us know that we have shaded in the right direction. Okay, this is a great way to check your work if you are unsure if you are coloring in the right direction, or shading, I should say. All right, let's go and try a couple of examples. Okay, I'm going to work through this first one here, example number 3. We are in standard form, so we always write our inequality to the side and we work it out. Okay, so the first step, minus 3x. Remember, we want to move that x term to the other side by doing the inverse. So we now have 2y equals negative 3x plus 4. Then we always divide by what we have next to the y, so it gets by itself. And we do this with every term. So 2 and 2 gone. We got this y. Negative 3 over 2, so we got a negative 3 over 2. We put our x out front. 4 divided by 2 is a positive 2. So we start with our y-intercept right here. Okay, positive 2 on the y-axis. And then we have a negative slope. Remember, negative slope is down and to the right. So we're going to go down 3 units, 1, 2, 3, and to the right 2 units. Down 3, to the right 2. Can I go down 3? Cannot, so I can stop right there. Then we go back and we do the opposite. So up 3 units, 1, 2, 3, and back 2 units. And that looks like as many dots as we can place. Then we want to look at our, whoops, I wrote equals. Pardon me, this should be greater than or equal to. So we look at this symbol. What does this mean? This means solid line. Okay. Whoops, I just borrowed from it. Let's put our negative back right there. And we have a negative slope, and it looks like we graphed correctly. Our shape appears to be going downward. So let's go ahead and graph this one. We have a solid line because of this underline, and we draw like so. Okay, let me fix that. And then we go back and look again to determine how we're going to shade. So we want all values greater than. Greater than means to go above. So I'm going to shade above this line. Okay, and another way to figure out how to do above or below is to look at your y-intercept. Okay, if I want greater than positive 2, what would be a value on the y-axis greater than 2? 3 would be greater, so I know I need to shade somewhere up above here. Okay, go ahead and pause the video, try number 4 on your own, and then come back and we'll see what you got. Alright, welcome back. So this is what I got right here. I got y greater than negative 3/4 x plus 2. Since I was greater than, I went ahead and drew or shaded above the line. Alright, I got 2 more examples for us right here. I'm going to walk through this one, let you do this last one on your own. This one, remember, you might have one of those special cases where you only have one of the variables. Okay, and this is either going to be your vertical line or your horizontal line. But using the axis should help you. If we know we only have the x value, we should be thinking about the x-axis, and we have this value 1. So we want to put a dot here at 1, and then we want to think about how would we cross the x-axis. If we went left or right, we would be the x-axis. We want to go across the x-axis. So that helps us remember that we have a vertical line, which is undefined. Okay, so we look here, we have an underline, we know we need a solid line, and we are going to draw that here like so. Okay, but now we don't really have an above or below, right? We can think about how we used to do things on the number line. Remember, if we said x was greater than, we went to the right. If we said x was less than, we went to the left. So let's think of an x value greater than 1, which is 2. So if you put a little dot right there, you would know to shade this entire section right here. We're taking all the values that are greater than 1 on the x-axis. Okay, so we are going to the right, and let me just make that look a little bit better for you, and boom. All right, go ahead, pause the video here, try this next one on your own, come back, let's see how you did. All right, great job. So if we took a look, we got rid of this 3x by doing negative 3x on both sides. Remember, I got this 0 here. I did not include it here because we don't really need to write the 0. We just need to remember that if there is no value here, that our y-intercept is indeed 0. Okay, I divided by -1 to get that y positive, and since I divided by -1, I had to flip my inequality sign, telling me less than or equal to 3x, so I had a slope of 3/1, and less than indicated to shade below the line. All right, so that is it in a nutshell, I believe. Yep, that is it. So hopefully you got some help from this video. If there's anything additional that you need, please let me know. Ask a friend for help, ask a parent, ask a family member, a teacher, anybody you know that knows some math. Maybe they can help you out with this. It's been a pleasure. Thank you for watching. I'll see you on the next video. Peace out.